Hello, everyone, and welcome to SUNUP. I'm Lyndall Stout. We often talk about the importance of soil testing for your farming operation, and for the most part, those conversations happen above the ground. But today, SUNUP's Curtis Hare is digging a little deeper with our OSU Extension Soil and Water Conservation Specialist, Dr. Daniel Adamson.
You know, we never really get the opportunity to look at what's really going on below our feet here under the soil. And Daniel, we actually have a great representation of exactly what is happening right here out in Stillwater.
Right, yeah. So Curtis, we were able to host the state land judging competition out here. So we had an opportunity to dig some soil pits, and it is always striking just what you can see underground, right? And one thing that people don't usually know about soils is they have very distinct layers. And we call those layers soil horizons. And the depth and the quality of those soil horizons really determines how productive a soil can be, or it can also determine how productive the soil can be for other uses that aren't agricultural as well.
And I see that you got this, labeled right here, A, B, C, and R. Now, pretty sure D comes after C. So what are we looking at here right with R?
Right, it was all very logical at first, right?
Yeah.
1, 2, 3, A, B, C, right? First 3 horizons. The last one is R because we hit some bedrock there, right?
Yeah.
So one thing you do when you're looking at soils, you want to understand what sort of material the soil developed in. So this soil developed in sandstone, and we can see this sandstone layer right here. And really everything above that is the soil, right? Because once we hit that bedrock, plant roots can't penetrate below that. It's hard for water to infiltrate below that. So really there's no productive ground below that level.
Okay, so let's just walk through what do we have here with these different soil profiles right
Right, so like we said, A, we start with is at the top, that's our topsoil. It's the surface soil horizon. It's the most biologically active layer of soil. So that's where we have all the plant roots growing into. You can see all this really nice root growth here. And that's where most of the microorganisms are active as well. And so that's where we're storing a lot of soil organic matter and soil carbon. And that's why we tend to see topsoil as looking more brown in color as well, right? And that's why intuitively we say if you have good black dirt, right? Good black soil, that's more productive. It's because organic matter makes our soils very productive. So if you go down to the next level, you see we lose some of that brown color slowly. The soil starts to get a little more red, and that's because this is our subsoil layer, and this is where we tend to get things accumulating in the soil. So as water and roots grow down, things move through the soil profile vertically, and we start to collect a lot of clay. So usually, remember last winter, Curtis, when we textured the soil, right?
I do remember that.
So this one's a little more sticky than the surface soil. It holds together better. So we're accumulating some clay in the subsoil. We're also accumulating some pigments like iron oxides that are making the soil a little more red in that layer as well.
And what about C?
Yep, so as you get below the subsoil, so this is our most active area of soil, you eventually get to the interface where that soil is starting to form, right? So we're getting close to that rock, and you can see we're getting in an area where we're hitting some of that bedrock, but it's decomposing through time, right? All that water and biological activity is slowly breaking it down, both physically and chemically. The difference between the C and the R is the C horizon, we could dig through this, but really it has very limited development. So that's kind of the bottom threshold of our soil before we hit the bedrock, which we see here.
Yeah, and this really tells you a lot. If you're a producer, you can really tell kind of really how shallow this is,
right?
Really, because you have a little bit deeper of a hole that I'm standing in, and right here it's still pretty much the same.
Yep, pretty well defined layer of bedrock here. So like you mentioned, Curtis, the depth of soil is really important for determining how productive the landscape can be. So in this case, because we're only about 25, 30 inches to that rock layer, it's really a relatively shallow soil. So you can see how a lot of the plant roots stop growing right at the interface of that rock. So really plants can't go any deeper. Plants can't utilize any water or nutrients deeper than that rocky layer. And therefore this would not be excellent farm ground because it's a little too shallow. So hence we're managing it as a rangeland at this point in time.
And I bet too, not just for production ag, this also has implications for, you know, maybe building a home as well.
Exactly, yeah. So, you know, sometimes biological things we want from the soil have different goals than physical things, right? So, you know, depending on how you want to build a foundation, or if you need a basement or something, or septic systems as well, these can all pose different challenges, right? So a lot of people in Oklahoma have a septic system. So if you have too shallow of a soil where you hit a root limiting or water limiting layer, then that septic effluent can't infiltrate properly and it can't treat that water, and therefore you're going to have different types of septic systems that you'll install around the home to get around that problem that we have with the soil as well.
You know, and right here you have a great soil profile with this hole, but you mentioned, you know, off camera that you have another one of these pits that's mainly clay, and you said it's basically like a swimming pool with all the rain we've gotten.
So in Oklahoma, obviously we're known for our red mudstone clays and shales, right? So that deep clay, that's just like this rock is influencing water movement, clay can do the same thing, right? So same soil pit, we're about 200 yards away from here, is full of water from the rains. It doesn't drain well because it's so clayey. So all the water movement is going to move through the subsurface along the A and B horizon, and it's going to stop when it gets to the clay. So again, even though the soil can be relatively deep and maybe doesn't have bedrock in it, it's all about how easily that water can move through it, and how plants can use it, and how living microorganisms can use it, and how we can manage the landscape around our homes and on our farms as well.
So I know a lot of people can't get out and dig a big hole like this in their yard, but you have a lot of resources available to help landowners and producers figure out what's going on with their soil.
Right, so obviously it can be kind of hard to interpret what's in your soil, but if you need some help, get in touch with Extension, and all of this information is available online on the NRCS's Web Soil Survey. There's also interpretations for different land uses there, so septic systems, basements, roads, and then obviously our different types of agricultural production as well. So if you're looking at buying a property and you just want to check and see what might be underground, there's resources available to help you understand.
Alrighty, thanks Daniel. Daniel Adamson, OSU Extension Soil and Water Conservation Specialist here at Oklahoma State University. And if you'd like some links to the things that Daniel talked about, just go to our website, sunup.okstate.edu.